So last week we were talking about the fats and oils, the glycerides. Pointed out to you that they were not long chains. Oh, I'm sorry, the lipids, which are made of glycerides. Now speaking of glycerides, it's going to get a smidgen confusing in a minute. Not difficult, just awkwardly confusing. But glycerides are not made of long chains. They do have parts, but they're not long chains like proteins and polysaccharides are. They are glycerol, which I pointed out to you was a very common ingredient in a lot of lotions and so on. And fatty acids, which are carboxylic acids with 20 or more carbon chains in them. And if you put a glycerol together with one fatty acid, you get a monosaccharide. Monosaccharides are not super common in living things. Disaccharides diglycerides, monoglycerides are not very common. Glycerides. Diglycerides are fairly common. Triglycerides are very common. And also, I should warn you, I just got a message that my internet is unstable. So I don't know, some days are better, some days are worse for the hotspot. We'll see how it goes. If I drop off, hang around, and we'll see if I can get back on. So what happens when I drop off, it's because I lost internet connection, so Zoom tries to reconnect, but I'm not connected to the internet, so then I have to reconnect as another person, as another participant. All right, so anyway, glycerides. Now, here's the part that is a little bit awkward. Notice that there are two subgroups. The glycerides, which is what we just talked about, the lipids. And then there is another group called steroids. Now, you've heard of steroids. Steroids have almost nothing to do with glycerides. They're not like another kind of glyceride. They're not another variation of glyceride. Steroids are a completely different group of chemicals. They're biologically 99.9% different from the rest of the lipids, the glycerides. The only reason they're lumped in here is because they're not water soluble. So here's why this is awkward. Lipids are often used as a synonym for glycerides. These two words are often used nearly interchangeably, but they really aren't interchangeable. They're used as if they're interchangeable, but they're not. Steroids are a kind of lipid, and they're occasionally used as interchangeable with the term lipid, but they're not exactly the same thing. Now, I guess I'm really not all that concerned that you sort all that out. I just want you to understand that steroids and lipids don't actually completely go together. That these two are used like synonyms, but they're not. Now, I'll get back to steroids in a minute. Glycerides, usually called lipids, commonly called fats in diet, except there are actually two kinds, fats and oils. None of this is hard, it's just used very loosely in language, and so we get mixed up because we've used the term so loosely. Oh, by the way, I wanted to point out before I got to fats versus oils, these are used for long-term energy storage and cell membranes. If you could get rid of every drop of fat in your body, which you can't, but if you could get every drop of fat, as in fat tissue, as in overweightness, you would still have cell membranes, and cell membranes are made of lipids. Remember the lipid bilayer theory? So cell membranes are made of phospholipids. And phospholipids are glycerol, G, like we talked about at the bottom of the last page, plus 2 fatty acids, which would make them a diglyceride, plus a phosphate group. The energy storage lipids are glycerol plus 3 fatty acids, usually at least. Maybe not always, I don't know. So that's why if you have blood work done, they'll look at your triglycerides and your cholesterol. Cholesterol is a kind of steroid. They don't check, that I know of at least, the phospholipids in blood work, because phospholipids are supposed to be in the cell membrane. I don't know how much they're floating around in the blood, other than in the red blood cells. So I don't know, maybe they show up there. All right, oils. Oils versus fats. Chemically, they're virtually identical, but there are some significant difference. Right here is the defining difference. Oils are liquid at room temperature, fats are solid at room temperature. Now, fats may be solid at room temperature, but fats are liquid at body temperature. So it says that oils are usually produced by plants, not exclusively, but to a large degree. Plants and cold-blooded, nope, that's the wrong term, ectothermic animals. Fats are usually produced by animals, specifically endothermic. So, and I suppose this will be a little bit gross or disturbing to some of you. If you're out randomly hunting whatever it is you're hunting, and you see one and you shoot it and then you field dress it. When you first field dress it, if it's got fat, the fat is soft and gushy because the fat tissue is filled with liquid at body temperature. And then after it's had a chance to cool off, that fat turns to a solid because it is solid at room temperature and below. So that white stuff, you trim off your, you might trim off a cut of meat before you cook it. It's solid, but then you put it in the frying pan or the whatever you call that pan that you use when you're going to put it in the oven and catch the fat dripping underneath. And you heat it up, and that solid fat starts to melt. And pretty soon, first thing you know, it's soft and gushy, and you have some running out to make what we call grease in the pan. But then you're done cooking, the pan cools off, and that grease turns back to a white solid. So fats are solid at room temperature and above, of course. Oils are liquid in room temperature. Why the warm-blooded, cold-blooded? Because cold-blooded things, they couldn't work if the fat was solid. Now, there is one other fairly important difference between them, and this is on average, it's not absolute. There are definitely exceptions to this. And that is that oils are usually unsaturated. Now, hopefully, you're figuring out by now that saturated refers to the number of hydrogen. They have a lot of double and triple bonds. They could hold a lot more hydrogen. Fats are usually saturated. Oils are usually unsaturated. Fats are usually saturated. Generally, we consider unsaturated fats to be healthier. That said, you have probably heard the term trans fats, which there probably is some great pun here, but I guess I won't try for it. You've probably heard the term trans fats, or possibly partially hydrogenated vegetable oil. Okay, partially hydrogenated vegetable oil is what we used to call trans fats. Partially hydrogenated vegetable oil is too much of a tongue twister, so somehow they became trans fats. So what trans fats, or partially hydrogenated vegetable oil, what they are is oils that have had hydrogen added chemically to make them more solid, less liquid. So there's this organic chemical called oleic acid. And I say oleic acid, and you might think bullfight, olay! But when I say oleic acid, you should think, if you've ever heard anyone say this, oleo. Oleo is what they used to call margarine, like in my parents' or grandparents' day. Well, oleic acid, or oleo, is a liquid at room temperature. And so they wanted to use it to make a butter-like substance, so they added hydrogen to it so that it would become more saturated and become solid at room temperature. The problem with the trans fats, or the partially hydrogenated vegetable oils, is that they are not, since they're done chemically in a factory, not in a living thing, some of them are not fully able to be digested by human bodies. And that's where some of the problem with trans fats comes through, is the fact that we don't have all of the enzymes necessary to digest them properly. All right, so oils versus fats. Liquid at room temperature versus solid at room temperature. Usually unsaturated versus usually saturated. Usually produced by plants, at least in our diet. The reason they say usually produced by plants, in our culture, we don't go around eating grasshoppers or insects, or generally speaking, cold-blooded animals. So we don't even think about the oils that might be in cold-blooded animals, the ectothermic animals, very much. We only think about the plants. If we lived in a culture, some of you have been to Africa, or may even have had like a chocolate-covered grasshopper. Yeah. If we did a lot of that, we might actually worry about oils, talk about oils being from ecto. Wait a minute. I put too many letters. Ecto? What am I doing? Ecto, no X, ectothermic. All right, the other group, steroids. And you have heard of steroids, and steroids generally tend to have this negative connotation in our culture because of their use um, for things like athletes to be stronger and so on. And there is no doubt that steroids are used inappropriately. But steroids is a class of molecules that is naturally occurring. All of our bodies make steroids, and the problem is that some people have used those steroids for inappropriate purposes or modified them to make synthetic steroids that did more of whatever that steroid was supposed to do, but may have had ill side effects also. So it turns out that steroid is part of another name that you may or may not have heard before. And I want to change here just a minute. So you can see the word I'm typing. You have heard the word cholesterol before. Cholesterol is where the word steroid comes from. You know what? I want to do this in a different browser so I can use the pen more easily. Okay, so cholesterol. Cholesterol right there is where the word steroid comes from. Or maybe cholesterol comes from something's wrong. S-T-E-R. I don't know if steroid comes from cholesterol or cholesterol comes from steroid, but they go together. This is the general formula. You do not have to know that formula specifically, but I do want you to know a real general form of it. So this is a lot of stuff that cholesterol does. This is a lot of pictures of cholesterol in the blood, because that's why we worry about cholesterol, is blocking our arteries so that the blood can't get through. By the way, about the time I was going into college, so late 70s, they were worried about all these people who were having heart attacks from cholesterol deposits. And they noticed that the Inuit, which, if you don't know, are the native people of Alaska and northern Canada, what used to be called Eskimos. They noticed that in the wintertime, particularly, the Inuit would have an almost, I know this is going to sound gross to us, an almost solid fat diet. They would eat seals and so on that were loaded with fat, and they'd have a huge amount of fats in their diet. And yet they had almost no problem with heart attacks and cholesterol. So we started looking at that for a while, and we came to realize that that was because in all those seals, and particularly the fish they were eating, there was a lot of, well, fooey, I just forgot the word. Yeah, omega fats, omega fatty acids, the things that you find in fish oil. And that's why now you can go down to the store and you can buy fish oil tablets that are supposed to help with cholesterol, help lower and protect from cholesterol. Well, anyway, what I want you to notice about this, if it'll load for me, try this again. No, it's not. Let's use this one. That'll work better. Well, it is not. Notice the orange rings. When I try and write on this, that one's, it goes away. Oh, it's up here. There we go. All right, notice these orange rings. This, if I were to draw a line here, let me make that more visible. Here's what I want you to know for the general structure of steroids. There is a 6-sided ring. So you should draw a 6-sided ring that looks kind of like this. And then there is another 6-sided ring right next to it. So it goes one and then straight across to the second one. And then there is another interlocking 6-sided ring, except this one doesn't go straight across. This one goes up to like 1 o'clock or 2 o'clock or whatever you want to call that. And then there is a 5-sided ring that again is straight across. So it goes across, up, across. The little arrows aren't part of it. That's just maybe to help you see and remember. So this one looks like home plate. So you've got 6, 6, 6. Oh, 6, 6, 6. And then a 5. And that is the generic formula, the most basic formula for cholesterol and for all steroids. All steroids have the same basic structure as cholesterol, the 6665 ring, but they have other R groups or other stuff coming off of it. So all steroids are based on that general structure, which has nothing to do with fatty acids or glycerol. So that should go right here in your notes, or in other words, you would have 6, 1, 2, 3, 4, 5, 6, and then straight across to the right, and another 6, and then up at this angle right here, and another 6. If you were good at this, they would all look the same. I'm not good at getting them all the same. And then a 5-member ring, a home plate or a house. So that is the generic structure of steroids. Steroids are used for hormones, like human growth hormone is a steroid. That's why people take HGH if they want to have more muscle. And human growth hormone won't make you grow bigger after you've quit growing. If you were to take it while you were growing, it would make you grow bigger. After you're done growing, like, if you're 25 and a baseball player, you take human growth hormone and it's going to make your muscles grow, but it's not going to make your skeleton grow. There are steroids. Okay, so some of them are hormones. Some of the steroids have anti-inflammatory. In other words, they stop swelling. So you may have a steroid inhaler. That has a steroid that is anti-inflammatory. It stops swelling. It is not going to turn you into a bulked up athlete. It has a different function altogether. So anyway, there you go. The fats, glycerides, and the steroids. Tomorrow, we will listen carefully. Tomorrow, we will have a Zoom meeting. I will not be covering notes. I will be giving you a PFG on the substituted hydrocarbons. You can get the PFG and sign off and turn it in later, or you can get the PFG and stay signed on and log on and ask questions if you have them, or you can get the PFG, sign off, work on it, sign back on if you have questions, and then sign back off if when your questions are done. But that's how tomorrow will work. So if you have any questions about today's material, you should ask. Otherwise, you are free to go, and we'll talk to you tomorrow.